I should record. Since we are talking about chlorate, you will notice that it looks like this. See, and when I draw it, I usually use the L like that, but on your chart, it looks like this. I'd like you to tell me what elements make up this polyatomic ion. Tell your partner what elements make up that polyatomic ion. This is hypochlorite. I'm going to give you two options. Option A, carbon, iodine, oxygen. Or option B, chlorine and oxygen. Tell your partner, do you like option A or do you like option B? I am hoping that by the name chlor, you chose chlorine. When you have an I, it's not super obvious in Times New Roman font. This is in Times New Roman font, but you need to get used to it because a lot of science stuff is done in Times New Roman. Why? I don't know. I think it was made in the 80s, 90s, and there we are. If you look at iodate, IO3, can you see what the I looks like as opposed to the L? The I has a little top bit and a bottom bit, whereas the L has no top bit and no bottom bit. Yes? So you need to be able to recognize that because I don't want you thinking that this is carbon, iodine, oxygen. It's a really common mistake. Okay, so watch out for that one. Okay? All right, I would like you to look at your table of polyatomic ions, and I would like you to notice how many positive ions there are as opposed to negative ions. How many positive ions are there compared to negative ions? There are only 2. And you may have come across this one in your homework. You might have come across a compound Hg2I2, which is weird, yes? That's because this is mercury with a Roman numeral 1. Okay? What that means is that each Hg atom has a charge of +1. However, what does this little number here tell you? It tells you there are 2 of them. So mercury 1 is bonded to another mercury 1. So you still have mercury 1. But it doesn't move around without its little partner. Mercury? What am I writing? Mercury 1. So just watch out for that one. It is a little bit weird, but it is what we've got there. So for example, when you have Hg2, I2, if you want to figure out the charge of the mercury, there's 2 ways to do it. First way is to write out all your ions. You have an Hg and an Hg, two of them. You have an I and an I, two of them. What's your next step if you're figuring out the charge of the Hg? Find the charge of the I. So we got -1 and -1. Next step. What do we do next? We add them up. -2. Next step. We need to say that the positive charge is equal to the negative charge. Just equal and opposite, because if we add these two, we should get 0. Okay? Now, in order to get +2, what is the charge of each individual mercury? +1, +1. So we can say I have mercury 1. Okay, if you prefer the crisscross, you can take the 2 up here and the 2 up here. So you end up with Hg. This 2 goes up here, 2+, and then this 2 goes up here, 2-. Do you remember what you have to do if you crisscross? You have to check and see if this is correct. Because if you didn't check to see if it was correct, you might think it was mercury 2. But is 2- the correct charge for I? No. So we need to take this whole thing and we need to divide by 2. So we'll end up with Hg +1 and I -1. Now we have a correct charge for I and we have a correct charge for Hg. So it is mercury 1. Okay, so that's relating the Roman numerals to our polyatomic ions. There's really only that one metal that forms a polyatomic ion. Mercury's kind of a weird element. It's the only liquid at room temperature. It's the only one that has a polyatomic ion made exclusively of a metal. Who is our other polyatomic cation? Ammonium. Okay, I would like you to note that this is different from NH3, which is a molecule. It is neutral. And does anyone know what we call NH3? Ammonia. Okay, so when you have the ion, it's ammonium. And you've got 4 hydrogens. When you have the neutral molecular compound, it's ammonia. And this one, I would ask that you please memorize, because you will come across it very often, both in Chemistry 11 and in Chemistry 12, if you should take Chemistry 12. So please memorize ammonia. When you are writing it on a test or a quiz, you can choose, what would we normally name this compound? If you were using the rules that we learned in the last few days, what would you normally name that? Nitrogen trihydride. I'm not going to mark it wrong if you write that, but if you write ammonia, that is also good, okay? Plus, if I write ammonia, you should be able to write NH3, okay? All right, negative ions. I'd like you to look through the negative ions and look at the name endings. Look at all the name endings in the negative ions and see what you see. It's probably easier to look at your page rather than mine. So what do you notice about most of them? Most of them are 8s. Yes? Most of the rest of them are 8s. And then there are 2 ides. Okay? 2 ides only. Where would you find most of your ide ions? Ide ions are mostly monatomic. What does that mean? Monatomic means one what? Atom. And where do we find one atom things? We find them on the, not hard, we find them on the periodic table, okay? On the PT, on the periodic table. All right, so for example, we have S2-, which is sulfide. So you'll notice we don't have sulfide on our table of polyatomic ions. We have sulfate and sulfite. But sulfide is found on your periodic table, okay? 2 exceptions to the ides are found on the periodic table. One is hydroxide, which is OH-. Are you familiar with that from your last couple years of chemistry? Yeah? Okay. I want you to take care. This is different from H-. Do you guys know the name of H-? Hydride. Okay, I want you to watch out for that. I noticed some people have been using hydroxide when they actually mean hydride, because I think we use hydroxide so often that it just kind of gets in your brain. Yeah, so if you see just an H, if you say NaH, it's not sodium hydroxide, it's sodium hydride. Okay? And the other one is cyanide. Yes? Hydrogen sulfide. Oh, yes, I did. Where did it go? Hydrogen sulfide is another one. Thank you for noticing that. And while we are down in this section here, I'd like you to take notice of the fact that HCO3 has 2 different names. You can either name it hydrogen carbonate or you can name it bicarbonate. Pick one. Do not name it both. Okay, so choose one or the other. But you need to recognize both, because if I give you a compound, we're going to go from names to formulas very soon. And if I give you hydrogen carbonate, you need to know it's HCO3. If I give you bicarbonate, you need to know it's HCO3. Okay, they mean the same thing. They're just different ways of saying it. Hydrogen carbonate is the official method. Bicarbonate is by far more often used. Okay? And I also want you to take note of these 2. I'm not quite sure why I've got them in 2 places, but just so you know, these 2 are the same. So if you want to, you can call that ion acetate. If you want to, you can call it ethanoate, and it doesn't matter which. Okay? Those 2 are the same. I'd also like to draw your attention to what is the difference between an 8 and an 8. In this case, the 8 has 3 oxygens and the 8 has 2. And I'm really sorry for this pen. It just does such weird things and it's driving me crazy. Let's take a look at another one. We have over here phosphate, which has 4, and phosphite, which has 3. Sulfate, which has 4, and sulfite, which has 3. So what can you, and also we have nitrate, which has 3, and nitrate, which has 2. What is the relation between 8 ions and their 8 counterpart? They ate more oxygen. The 8 ions ate more oxygen. They ate 1 more oxygen than the 8s. Now, do you need to know that? Not really, because they're all on your table. But at some point in your chemistry career, it's kind of nice to like just know a few ions. And if you know nitrate is NO3, then you also know nitrate is NO2. And I'd like you to notice that the charges of the 8 and the 8 are the same. The charges of sulfate and sulfite are the same. The charges of nitrate and nitrite are the same. So if you start, because some of you this year are definitely going to start knowing a lot of these ions by heart just because you've used them for 2 years already, right? And you're using them again this year. So if you start picking up on those, if you know those little patterns, it'll help you just know things and then you don't have to look things up as much, okay? Just it speeds things up for you. Okay, so let's go back to page 44. So a binary compound is made of 2 elements. What is the cation? Is it a metal or a non-metal? Cation is a metal. The anion is a non-metal. Now these ternary ionic compounds are made of 3 or more elements. The cation can be a metal or it can be a, what is the other thing that we call those ions? Those ions we were just looking at are called polyatomic ions. There are only 2 polyatomic cations, and we just looked at those. Those are ammonium and mercury 1. The anion can either be a non-metal or a polyatomic ion. And there are lots and lots of polyatomic anions. So when it comes to naming these polyatomic anions, or actually these are for writing these are the binary ones. Don't forget, when do you use a Roman numeral? What kind of element do we use Roman numerals for? Do we use them for metals or non-metals? We use them for metals, but only for metals that are multivalent. Tell your partner what multivalent means. Two or more possible charges. And where do we find the metals that are multivalent on our periodic table? In the red zone. Now, is there anybody who needs a red zone periodic table? Do you need one, Jerome, or do you have one? You have one. Excellent. Do you have one, Alicia? Yeah. Yeah? Okay, good. So let's take a look. We name the cation, either metal or ammonium. And you need to use a Roman numeral when you need to use a Roman numeral, same as before. And then we name the anion, and we don't change the name to "ide" if it is a polyatomic ion. We just name it like we name it. So here we have, and mainly the problem with these is sometimes people have difficulty figuring out where one ion begins and the other ends. Fortunately, you've done these for 2 years now, so it's not quite as weird. Where does the first ion end? NH4Cl. After the 4, okay? That's the cation. Is this a Ci or is this a Cl? Cl. You're never going to see a Ci. You might see Ci4 as a, what do you call it, covalent compound, but never in an ionic compound. Okay, so that's our negative ion. So we just name ammonium and then chloride. We have manganese, which is in the red zone. And we have carbonate. CO3 is 2 negative. So there are 2 ways of finding the charge of that manganese. You can either write out Mn, 1 Mn, and 2 CO3s. What do we do next? Add up the total negative. Remember, the whole compound has to equal 0. So what's the total positive charge? 4 positive. And there's only one atom, so that atom has to be 4 positive. And therefore, our Roman numeral is 4. We have manganese 4 carbonate. What if you wanted to uncrisscross? Mn, CO3, 2. Let's bring that 2 up here. What are we going to bring up beside the CO3? There's a 1 here, yes? So we have Mn, and the 2 comes up, 2 plus. And we have CO3, 1 minus. But remember, you have to check. Is this correct? Is carbonate 1 minus? No, it's 2 minus. So what do we need to do to the whole thing? We need to multiply by 2. So we end up with Mn4 plus and CO3 2 minus. Either way, whichever way you prefer to do those is good. How are we feeling about that? Pretty good? Okay. FeCN3, Fe, Cn, Cn, Cn. We have 3 CNs. You'll notice, what do we put around our polyatomic ion? You have to have brackets around a polyatomic ion when you have more than one. Can I call them PAIs? Polyatomic ions? PAI? More than one polyatomic ion? Use brackets. That's going to come in handy when we go backwards to the formulas. You look up cyanide, it's got a -1 charge. What's the total negative charge? -3. That means our total positive charge is +3. There's not more than one iron atom, so all of that 3+ goes here, and that means that this 3 is what we use as our Roman numeral. You could uncrisscross this. Fe1, Cn3. The 3 comes up beside the Fe. The 1 comes up beside the Cn, 1 minus. And we can say, is that the correct charge for Cn? Is Cn -1? Yes. Therefore, this is okay as it is, and it will be Fe3+. Okay, so if the charge checks out, you can just leave it alone. Last one, calcium carbonate. CaCO3. Now, I know calcium does not need a Roman numeral, but let's pretend it did for a moment. Okay? People get messed up by this because they start doing things like this. CO, CO, CO. Don't write that down. What's wrong with what I have written? There are 3 oxygens, not 3 COs. If there were 3 COs, I would have had brackets around that, yes? So there's not 3 COs. So I want to get rid of that. What do I have here? I have CO3, and how many of them do I have? Just 1, right? Okay, so watch out for that. Also watch out if you were to try uncrisscrossing this. Sometimes people might be like, okay, I'm going to bring that 3 up here. No, that 3 belongs to carbonate. It is not like it's not an ion charge balancing subscript. Okay, so if that confuses you, go back to doing it this way where you've got a 2-, which means this is 2+. And I know we don't have to do that for calcium, but anyway. All right. This is just, okay, because I honestly, I was too lazy to make a brand new book for my grade 9s and my grade 11s. So this is what I did with my grade 9s. So if you have problems recognizing where the cation ends and the anion begins, you could do this part where it's just saying, this is my cation, this is my anion, this is my cation, this is my anion. Your choice as to whether you feel this will be useful to you or not. Okay? So page 46 is optional. You might want to take a look at, say, this one here, and this one here, and this one here. I'll just pick out the ones that I think might be more confusing for you, and this one here, and this one here. Try those ones. See if you can pick out who is the anion and who is the cation. Page 46. If you want to do them all, you can do them all, or you can just do these ones. with the stars. Alicia, grab your phone into this. Oh, okay. Okay, yes. Yeah. You can start on quiz 5. If you feel ready for it, you can go right ahead. You're at the table, which right from? Where did I pick them? Gonna make your life so much easier. Yeah. I mean, you can do the rest of them if you want to, but once you're done, you can check your answers up here. One thing I want you to notice, are there ever more than 2 different ions? Is there ever like a ion? No, it's always just positive ion, negative ion, positive ion, negative ion. All right. So you can, if you want to, work on page 53, 54, and 55. Or if you want to go straight for like the mixed up ones. Oh, no, that's okay. Page 53, 54, 55. Okay? Yeah. Now, those of you who have not written quiz 4, now might be a good time to do quiz 4. And I will get your quizzes from last day back to you. Excellent. Let's take a look. Just bromide. Oh, yeah. Yeah. Okay. Yeah, they're looking good. Okay. Yeah, those look great. Okay, so I'm going to give you a 6 for that one because you're done. Okay. So, I don't need them in. Yeah, I've looked at them. What have I done with all my pens? There we go. Okay. That was Kim. All right, listen for your name. These are quizzes from last day. V, Megan, Lauren. Oops, 2 for Lauren. Awesome. There we go. V, Azin, Caleb. Oh, let's think of the other guy. Go, Marco, Gian, Wilfred. Wilfred went to the washroom. Caleb. I'll just put it there for you. Jerome, Leo, Aaliyah. Hi. Yes.
I'll just make
Leo's not here today, right? Aaliyah, there you go. Marco, Nathan, Sky.
I'm waiting for my
Sky, sorry.
Thank you.
Marco, Nathan. Adam, Gian. Anthony. You can take that one right there.
This one?
Yeah.
What about
Lauren, Steffi.
Oh, do I not need to put in Roman numeral?
That's right. No, not when it's only one, but it's not in the red zone.
I know it's weekend.
Rajan, Jenny.
Oh.
Hi. Oh, let me grab one for you. Yeah. Oh, you're anyone need the red zone right on the table? Or are we good? There we go.
Is that number 4? What?
Yeah.
What you get?
Okay, let's see. And I've got a few quizzes from before. I've got Christy,
I got the sodium one.
Fung. Got a couple for you here. 1 and 2. There we go. Christy, Jaron. No Jaron.
Oh, no.
Wilfred. There you go. All right. Oh, Jaron left to go to the thing, right? And if you finish quiz 5, you can do mixed naming, which basically just means it's got all the different kinds, and that would be on page 59. Thank you. Megan.